Hello friends, I welcome you all to this class. Remember in our last class we introduced this topic line integral, and we solved a particular example, and I told you that we are going to consider more examples on this. So we want to solve more examples on this line integral. I told you that line integral is an integral which is performed along what? A specific curve. The curve could be a circle, triangle, rectangle, and so on. So we have this example to consider. We have to evaluate integral over c, over the curve c, integral over the curve c of f bar dot the r bar, where this f bar is equal to xyi plus y exponential xj along the rectangle. So the curve c is a rectangle now. It's a rectangle joining the point 0, 0, 2, 0, 2, 1 and 0, 1. If c is transverse in the counterclockwise direction, that's in anti-clockwise direction. So if you are to calculate line integral, if the curve is rectangle or if the curve is a triangle, you try to sketch it. So you try to sketch it. So I'm going to write solution. I'm going to try to sketch that curve. This is our origin, right? So the curve, the point will have 0, 0, right? That's this point. This is our x axis, this is y axis. So we have 0, 0. So here now, this point here is 0, 0, right? That's this point, the origin. And I will call it a point A. So what's the next point? 2, 0. What the first point is what? The first entry should be what? For x. The second entry should be what? For y. So at this point, x is 2, y is what? 0. So which means that this point is at line, since y is 0, this point is at line x. So okay, let me just call here 1 and call here 2. So at this point, x is 2, y is 0. So let me call this B. So the next point is 2, 1. So at this point, x is 2 and y is 1. So see point, x is 2, we trace, x is 2, go up. Y is 1. So let me call here 1, for y, call here 2. So at this point, x is 2, y is 1. So we'll go like this, x is 2, y is 1. So here is this point, 2, 1. So I will name here C, point C. Okay, let me change the letter because I don't want to name here C. Since our curve is C. So let me use P, Q, R. Let's use this one, P, Q, R. So the next point now is 0, 1. So the first entry is for x0, y is what? 1. So y is 1, x is 0. So is this point 0, 1. So I will call this place S, PQRS. This forms a rectangle. This is our rectangle we are looking for. This forms the rectangle we are looking for. I'm drawing the arrow in anti-clockwise direction. They say it's going in counter-clockwise direction. That's anti-clockwise direction. So you are going to perform this line integral first from P to Q, then from Q to R, and then from R to S and S to P. So you are going to go like this to perform the line integral. So the next step is to get this F bar dot the R. But let me write our dr. Our dr bar will be equal to the xi plus the yj. So we are going to stop at j because our vector stopped at j. If your vector stopped at k, you are going to do the xi plus the yj plus the zk, right? So we are going to do f bar dot the r bar, because let's dot this. I component multiply I component. I component here is xy multiply I component here dx plus component multiply j component. J component here is what? Y exponential x. Multiply j component here, dy. So integral over c of f bar dot dr bar will be equals to integral over c of. So what do we get in our dotting? We got xy dx plus y exponential x dy. So this is now what we have. So we are going to have integral over c1 of x y dx plus y exponential x dy. So let's perform over the first for the first curve. Your c1 is from this p to q, right? So at that point, so for c1, x is equals to x varies, right? Look at the c1. From c1 is going from 0, 0 to what was this point? 2, 0. What do you notice for c1? X varies, y is what? Fixed, right? X is going from 0 to 2, but y is 0 here, is 0 here. That's y is fixed, y did not change. So for that one, y is equals to 0, right? For that one, y is fixed. So if y is 0, which implies what? I can get this dy here. So dy will be equals to what? 0 too, because y is 0. Changing y will be 0. So I'm going to substitute y for 0 in this. So if you put y for 0, this implies. So what do you have here? Integral over c1, we have 0 dx, and this is 0. Because y is 0 at this point, so if you put y for 0 here, put y for 0 here, and the y2 is 0. So this whole thing goes to 0. And we are going to have that integral over c1 is what? 0. So let's get integral over c2. Integral over c2, we are having xy, right? Xy dx plus let's copy from here, y exponential x dy. So that's what we have, because this is our f bar dot dr gave us this. So I've written it down. We are integrating over c2. That's this place now. This one we are moving anti-clockwise. So we are moving from this point to this point. So it means for c2 we are going to move from 2, 0. That's the first point to the other point, 2, to the other point, 2, 1. What do you notice from moving from here to here? X is 2 here, because x is the first point. X is 2 here. So x did not change. It is y that changed from 0 to 1. So we are going to say that one did not change. You write, so you are going to have x is equals to what? 2. X did not change. So since the x did not change, you are going to be integrating this over what? Y, because it's y that changed. You are integrating this over y. So x is 2. It means anywhere I see x, I will replace it with the 2 with 2. So I will get change in x. That's the x. So if x is 2, it means since x is just 2, a constant, if you differentiate 2, you get what? 0. So it means that the x is 0. So this implies that integral over c2. So what do you have here? X is 2, but the x is 0. So if you put the x for 0 here, this whole term will go to what? 0, right? And if you come here, you have y. So I'm going to have 0 plus, here will be y exponential. Remember, x is 2. So instead of exponential x, I'm going to say exponential 2. Then dy. Right? I'm going to integrate this over y. So this will be integral. What is the range of y? From y goes from where? Y changes from 0 to 1. So I will say from 0 to 1. That's y changing from 0 to 1 of y exponential 2 dy. But exponential can come out, so I'm going to have exponential 2 integral from 0 to 1. So if you integrate y, what will you get? So this will be exponential 2. Integration of y will give us So index of y is 1, right? If you add 1 to 1, you are going to have 2. Y raised to power 2 divided by that 2, right? Then evaluated from 0 to 1. So if you put 1 for y here, you are going to have what? If you put 1 for y here, you are going to have 1 squared is 1. You are going to have 1 over 2. Multiplying exponential 2. Have 1 over 2 exponential 2. Exponential 2. Then if you put 0, for y here, this will go 0. So just this will be minus 0. So this is just 1 over 2 exponential 2. So this is what we have for C2. So let's do for, remember our C1 gave us 0, right? Our C1 gave us 0. So integral over C3. Let's write what we have: xy dx plus y exponential x dy. So for C3 we are moving from here to here. So we are moving from R to S. Point R is 2, 1 to point X is what? 0, 1. 0, 1. So what do you notice? It implies that what? Y is fixed. Y is 1 here. Y is 1 here. Y is the second component. But X is the one that changed. So since X changed, you are going to be integrating over with respect over the interval of X. So since Y is fixed, you write what Y is. Y is equals to 1, which means you replace Y with 1 anywhere you see it. And if you differentiate 1, you are going to get what? 0. So the Y will be equals to 0. So I'm going to replace the Y here with 0. So my range of X is the one that varies. So X is starting from 2 to 0. Right? So I'm going to have from 2 to 0. Right? X is starting from 2 to 0. That's from this point, from 2 to 0. So, and we are going to have Y is 1. So I'm going to put 1 here. 1 multiply X, I'll have X. Then the X. Then if you put the Y for 0 here, this term will go 0. So this is what we integrate. So if you integrate X, you add 1 to the power, you have 2 over 2. Divided from 2 to 0. If you put 0 here, this will become what? 0. Put 0 for X becomes 0. You have 0 minus, right? If you put the lower range, 2, put 2 here, you are going to have 2 raised to power 2 over 2. So this is 0 minus 2 raised to power 2 over 2 will give you what? 2. So 0 minus 2, which is minus 2. Let's look at C4. Integral over C4 of what we have is x y dx plus y exponential x dy. So that's what we got in our f bar dot dr. So I'm integrating. C4 is moving from S to P. So for C4 we are moving from S to point S is 0, 1 to point P is 0, 0, right? So what do you notice here? X is fixed. X is 0. X is 0. So it means anywhere you see X, you put 0. Y changed from 0 to 1. It means we are going to integrate over the range of Y. So Y we write down the X is 0. So this implies that our change in X, if you differentiate 0, you get what? 0. So anywhere I see X, I'm going to put 0. And change in X, even the X2 is 0. So this implies, so the range of Y is from 1 to 0. So I have 1 to 0. That's the range of Y. So we're integrating over Y. So if you put X for 0 here, this term will go 0. So remaining this term. So you are going to have, and if you put X for 0 here, you have exponential 0 is what? Exponential raised to power 0 is 1. 1 multiply Y, I'm going to have Y dy. So, and if you integrate Y, you add 1 to the power of Y, it becomes power 2 divided by that 2. Divided from where? 1 to 0. If you put 0 for Y here, you put the upper bound, right? Put 0 for Y here, you get 0. 0 minus, put 1 for Y. 1 squared is 1 divided by 2. So what do you have? Negative 1 over 2. That's negative half. So I'm going to write the answers we got. I'm going to write the answers we got. So this will be equal to, remember, for the C1 we got 0. Right? For the C1 we got 0. You can pause the video and check. We got 0 for curve C1. For curve C2 we got 1 over 2 exponential raised to power 2. Then for the C3, our C3 is still here on the board. We got negative 2. And plus our C4 we got negative half, which is still there here. So this will now is now what we have. So we have basically half exponential raised to power 2. Then let's add this together. Negative 2, negative half will give you negative 5 over 2. So to give you negative 5 over 2, of course you can bring half out. So you are going to have half into exponential 2 minus 5. So this is the value of that integration over that very curve C, which is a rectangle. So thank you so much for being part of this class. See you in our upcoming class. Bye.